Okay, this is the second half of the 8.3 notes. I didn't really include this in the notes, but I handed these out in class. It's not. It is a worksheet, but I didn't have you guys turn it in. I just wanted to show you guys some sample problems, and we did these in class. First thing I want to do is I want to zoom into these shapes down here, and I want to ask you whether or not we have enough information to determine whether each one of these shapes is a parallelogram or not. So for this first one, is this a parallelogram just based on the information given? Well, these two diagonals, or I'm sorry, this one diagonal is cut in equal parts, and this one diagonal is cut in equal parts. So the diagonals bisect each other, therefore, yes, this is a parallelogram. Let's go to the next one. Here I have opposite sides congruent, but not these opposite sides. So this is not a parallelogram necessarily yet. If we knew that these two sides are congruent, then yeah, we could say this is a parallelogram. Or if we knew, hey, that these sides were congruent and parallel, then we could say that this is a parallelogram. So that's not enough information originally. How about this one? Well, this one has opposite sides being parallel and then these two sides being congruent. Well, that's not enough information because this side could be a little bit longer and it could end up looking more like a trapezoid. So no, that's not enough information to tell that this is a parallelogram. So I'm going to put no. I'm going to say we either need to know that this guy is congruent with the thing on top. Yeah, that's what we need to know. That's the only other thing I can see right off the top that would help us make this a parallelogram. Alright, how about this one? Well, opposite sides are congruent and opposite sides are congruent. So yes, this is a parallelogram because opposite sides are congruent. So you can kind of see what we're doing here. We're checking to see each of these. So what I want to do is I'm gonna kind of zoom out, and on these last four I want you to try them on your own. Just kind of look at them and see if you think there's enough information. So you may want to pause the video and try for yourself. I will put the answers up there in a second. Okay, for 17, it's a little bit tricky, but we have an angle, and really we have two parallel lines here cut by a transversal, making these, sorry, not necessarily parallel, but we do have two lines cut by a transversal whose alternate interior angles are congruent. When alternate interior angles are congruent, it means that these lines are parallel. So the same thing is true left to right. I have alternate interior angles, so these two lines are parallel. And if that's the case, then yes, this is a parallelogram. So there is actually enough information in that drawing. Let's check this one. I have one pair of opposite angles congruent, but I don't know anything about these angles. And if I wanted to, I could kind of draw this. Don't laugh at my drawings, but if I wanted to, I could kind of draw this like this. Look, opposite angles are congruent, but the thing is not a parallelogram, it's a kite. So this could be a kite. So that's why we don't have enough information. So we would say no. If it was a parallelogram, we would have to have these angles being congruent as well. Okay, and 19, we have opposite sides that are congruent, and those same opposite sides are parallel. So yes, this is a theorem 8.12. It is a parallelogram. Okay. And here I have opposite sides congruent, but I don't have these opposite sides congruent, so that is not enough information. I either need those two sides to be congruent, or I need these sides to also be parallel. So this one is a no. Okay? One more thing I want to point out to you guys. You might see a problem like this, and I'm going to let you see the directions. It says, find the value of x, then tell whether the figure must be a parallelogram. Explain your answer. So they're not telling us that this is a parallelogram, so we cannot use any of the properties of parallelograms to solve this. So what properties can we use? Well, let's take a look. It's not necessarily a parallelogram, but it is definitely a quadrilateral. It has four sides. So that means that all of these four angles should add up to 360. So that's what I'm going to do. I'm going to write 360 plus, or I'm sorry, 360 equals x plus 30 plus 3x minus 15 plus 2x plus 2x plus 25. Alright, well, let's combine some like terms. I have 1, 2, 3, 4x, 6x, and 8x. So let's write that. 360 equals 8x. And then for numbers, I have 30, negative 15, and 25. Well, 30 and negative 15 just make 15, and 25 and 15 make 40. So there we go. 8x plus 40 is a simpler way to write the equation, or the sum of all those angles. Do a little algebra, subtract 40 from both sides, and I get 320 equals 8x, and then divide both sides by 8, and I would get that x equals 40. So if x equals 40, I can plug that back in. Well, x plus 30 is 70. And I'm going to just go ahead and check this angle right here, because if these two opposite angles are congruent, then we know this is a parallelogram. If they're not, then it's not a parallelogram. So let's see. 2x, 2 times 40 is 80. So these two things are not congruent, therefore, no, this is not a parallelogram. As much as it looks like one, it's not. So those are some ideas, some samples of problems you're going to see. Yeah, talk to you guys later.